The PERN Stack is very reliable. With the database running on PostgreSQL, the server running on Node and Express, and the client running on React, you can build pretty much any application with it. In this video, you're going to learn how to use it to build a to-do list application from scratch, step by step. So let's hop on the computer to get started. So this is the application that we're going to be building. It's a very simple to-do list application that allows to create, read, update and delete to-dos basically. And as you can see, we have here a couple of to-dos. We can check and uncheck them. We can also delete, and if we want, we can also go ahead and add again, check the emails, for example, and create a new task, and then the task gets created, and we can, again, the same way as we did with the other to-dos, we can check and uncheck this and delete it again. And if we go ahead and refresh the page, you can see that this remains the same as it did before, which means that the data is stored in a PostgreSQL database and we'll always see the same thing each time that we come back to the application. Alright, so I'm now inside of VS Code and I've created an empty folder for us to house our client and our server projects, and then we're going to basically communicate between the client and the server in order to build this full stack application. So we're going to start with the server, we're then going to test the server in a REST client, and finally we're going to build the client using React. So with that said, let's get started, and we're going to get started by creating the server folder. So now, after creating the server folder, I'm going to cd into it, and we need to initialize first of all the node project. So in order to do this, we need to run yarn init and then answer these questions, which I'm going to leave all of them blank. So as you can see, after we run yarn init, it basically creates here a new file that's called package.json, in which this file is going to house our dependencies, our dev dependencies, and also our scripts that we're going to use in order to run commands from the terminal and then run them inside this server project. Now, before we go ahead, I'm going to just create right over here a .git ignore file. And before I do this, I just want to let you know that you don't have to do this. I'm just going to do this in order for VS Code to basically not index this folder inside the search, so I can go ahead and create this tutorial faster and not be confused with the different files that are inside the node modules. But again, you don't have to do this for yourself if you don't want to. I just explain it to you so you're not confused about what this file is doing right over here. Now you can go ahead and close this file, and after closing the file, we'll go ahead and install the first packages that we need in order to run this project. So the first dependencies that we need are, first of all, we'll need to install Express, then we'll need to install Course, then we'll need to install also body parser, and finally TypeScript. So Express is the library that we'll use in order to run the server. Course is going to allow us to communicate between the client and the server. Body parser is going to parse the JSON, and finally I'm going to use TypeScript because I prefer to use it. I always prefer to have type checking inside the projects that I'm working on, and it is a subset of JavaScript. So if you already know JavaScript, you can also go ahead and follow this tutorial and use TypeScript inside your project. So with that said, run this command in order to add all of these libraries to your package.json file. So as you can see, now it added here not only the dependencies object, but it also added inside of it body parser, course, express, TypeScript, and its versions. Next, we want to add the tsconfig file, and in order to do this, we need to go ahead and run inside the command line npx tsc --init, and this is basically going to create again a tsconfig.json file with the default configuration. Now we need also to add as dev dependencies the types for body parser, course, and express, and we also want to add node daemon and ts node. So in order to do that, just run yarn add -d, and this -d is going to tell basically yarn that we need to add this instead of dependencies as dev dependencies, and then again you want to add express, cores and body parser in order to have type checking for these libraries. And finally we want to add node daemon and ts node that are going to be the tools that we'll use in order to run this server in dev mode. So now we have all the libraries that we need in order to run our basic server, and with that done we can now go ahead and create inside the server folder a new source folder, and inside the source folder let's go ahead and create an index.ts file, and this file is basically the index file, which means that the entire application is first of all going to run through this file before it gets to other files and before it gets to run the code in other files. Now we're going to start by creating a simple hello world just to make sure that the server is running and to basically create the skeleton for the application. So in order to do that, we'll need to first of all start by importing express from express. Then we also need to import cores from the cores library, and then we need to import the JSON object and also URL encoded from body parser. So these are the three things that we need in order to import in order to start creating a basic server. Now with all of this imported, go ahead and write the following. First of all, define app, the constant app, as express, and make sure that you run this as a function, because only if you run it as a function it gives you back the things that you need. And then let's define also the port that we're going to be using to run this server. And finally we need to add the following code in order to make sure that all of this works together. First of all, write app.use, and then inside of use, inside the use function, you want to add cores and also as a function. Then we want to do the same thing, but instead of adding cores we'll add JSON, which is the thing that that's basically going to parse the JSON. And finally we want to do the same thing but add URL encoded, and the options we're going to set extended as true. So again we're going to basically add here the express app, then we'll basically use cores, JSON and URL encoded. Now in order to make sure that this server is listening on the port that we want, we need to add the following code. First of all, add app.listen, that we want to define the port, and then we want to pass here a function, and if all of that goes well and if this is successful, we want to console log a message that says that the server is ready. And then we'll say that it is ready at http localhost, and then we'll define the port right over here. And again, once we start this this server, if all of this goes well and if the server is started correctly, we'll get back this message letting us know that the server is ready at localhost, and it is also going to let us know in which port. So for example, if we go ahead and change this port to 3001, it will go ahead and also change not only the port that it is listening to, but the message is also going to reflect that. Now we want to basically set up now the base route. So each time that we make a get request to localhost 9001, we want to get a basic message that says hello world, letting us know that the server is running and that the requests are also working. So go ahead and write app.get, and then we'll define the path, which is this right over here, as we'll just add a slash, which means that it is the default path. And then inside this function, express gives us two different things. First of all, it gives us the request object and then the response object. Now because we're just going to go ahead and answer, we're basically going to give back a simple hello world message just as a string. We do not need in this case the request object, so we can just write here an underscore. and then we're going to pass the response object as res, and finally we'll do the following. We'll write res.send, and inside of here we're going to send a basic message that says hello world. And finally, in order to make sure that this entire application runs, we need to export the constant app. So go ahead and write export default app, and make sure that you write here default. Don't just export right over here. You need to export it as default inside this file. Okay, so now that we've set up a basic Express server inside this index.ts file, we need to make sure that we can run a command inside the terminal in order to start it. So here's exactly how we're going to do this. First of all, navigate to the package.json file and add here a new key that says scripts. And as you can see, this becomes an object, and now inside this object we can add a new key that says dev, and then the value is going to be no daemon, which is what we're going to be using in order to run the dev server. And then we're going to execute ts node, and we're going to tell no daemon and ts node to run this file basically that we just created, which is located inside source and then index.ts, which stands for TypeScript. Now, if we've done all of this correctly, we can go again inside the terminal and just write run yarn.dev. And as you can see, this is now starting the server, and then it is ready. As you can see, the server is ready at localhost 9001, which is the message that we defined right over here. Now, using a REST client, for example Insomnia, which is the one that I'm using, or you can use Postman if you prefer it, we're going to make a simple GET request to 9001 just to make sure that the request is working. And as you can see, it gave us back the hello world message, which is the string that we defined right over here. And this tells us that the entire server is working and the requests are also working. Now we can go ahead and stop the server, and now we need to install the libraries that we're going to be using in order to communicate with PostgreSQL and in order to define our models. So here's exactly what you need to install. First of all, go ahead and install objection, which is an ORM, and basically this is a way for you to communicate with PostgreSQL without having to write the queries from scratch. Then we're going to install Knex, which is what objection is based off. So in order for you to use objection, you always need to install Knex. And finally, in order to use PostgreSQL, so this tool also works with MySQL and other type of SQL tools. So in order to use it with PostgreSQL, we also need to install the library PG. So basically, again, you need to write yarn add objection Knex and PG and go ahead and run this command. Now that we've installed the libraries that we need in order to communicate with the database, I'm going to go ahead and create inside the source folder a new folder that's called DB, and it stands for database. And inside of this folder, I'm going to create a new config.ts file, and this is going to hold the configuration for objection and for Knex. And inside this file, you want to write the following. First of all, export it so we can make sure that this gets exported. And then we want to set the key of development and add inside of it the following. First of all, define the client, which is PostgreSQL. So we want to make sure that we let the tools know that we're using PostgreSQL, and then the connection parameters. So basically we need to set the host as localhost because we're working inside our localhost machine. Then the port is going to be 5432, which is the default port for PostgreSQL. Then the database I'm going to set as todos dev, which is the project name that I've defined for this project. And then the user, which is the username, is Emmanuel, which is my my local machine username. And finally, the password is going to be password. So basically, these are the credentials. I think inside of PostgreSQL, you can just define any type of user, but because my username inside Linux is Emmanuel, I've defined Emmanuel as well, so it can be easier for me to access the databases. And the password is something very simple, because we don't really need to worry about a complex password, because if you're using a firewall, no one's going to have access to your local machine, and it doesn't really hold a lot of valuable information. So now continuing, we need to add here pool, and we're going to set the minimum as 2 and the max as 10. And finally, we need to add here the migrations key and set the directory to dir name plus migrations. So what this dir name basically says is that it's going to access this file, this folder right over here, and then inside of this folder we're going to later create a migrations folder. We're also going to set the table name for the migrations, so Knex can keep track of all of this. And then we're going to set the extension as TS, so we let Knex basically know that we're working with TypeScript files instead of just JavaScript files. And then finally, in order to make sure that when we import this into the next file that we're going to be creating, you want to add the following. Just write as, and then set this as a key and string, and then as an object. So basically we're telling TypeScript that this thing right over here as a key has keys that are strings. So for example, development is a string, and then inside of this it is an object. It doesn't really matter the structure of the object. We're not really going to be touching this a lot, this file, so we can just leave this as is. Now the next step is for us to create our next file, and we're going to do that inside of the DB folder again, and we're going to call it next.tx, and we're going to start by importing Knex from Knex. Then we're also going to import the following from objection. We're going to import Knex snake case mappers, and what this means is basically we're going to define inside a database. So for example, if you have our title inside a database, on the code, when we basically query things from the database into our code, it is going to appear as our title, because it is better to work inside of JavaScript and TypeScript files like this instead of using snake case. And finally, we need to import in a different way. We're going to first of all define the constant of config, and it equals require config. So basically we're importing this configuration file that we've just created before. And finally, we need to define the environment. So we're going to define this as process.env.node.env, and if we don't have any node environment defined, we're going to use development as a default. And basically this means that if we are on production, this basically helps you if you want to later put this on production. You can go inside this file, create a new key that says production, and then once you start your server, you can start it with the node env of production, and it is going to connect to a different database that you can define here or just with an URL. That's why we are creating this environment right over here. And finally, we want to export as default Knex. We're going to export the Knex object, and inside of this we're going to deconstruct first of all the config, and then we're going to use the key of environment, which in this case is going to be again development. And finally, we also want to pass this function that's basically going to help us. Basically, objection is going to again map snake case to basically, if we again write our title, it is going to leave us with our title like this inside the JavaScript code. Now that we have this file right over here created, we can go inside the index.ts file, and we need to start by first of all importing the file that we just created. So we're going to import it from DB and Knex, and then we need to also import model from objection. And with these two things imported, we can go ahead and write model.Knex, and then inside of here we need to pass a Knex configuration, and we're going to pass the configuration that we just imported from this file right over here. And this is the final step in order to set up basically the connection between objection, Knex and PostgreSQL. Now the next step is for us to create the migrations for the to-dos. But before we do that, and we go ahead and create first of all the migrations files on the terminal, and then use the file in order to define the migration, we first need to go inside the package.json file again and define the following. Write Knex here, and then inside and then the value is going to be Knex file, and then we're going to define the Knex file as source db and config.ts. So basically if you just install globally, for example, Knex in our system and then run, Knex won't know where it is, and we can tell it where it is by using this flag right over here, which is Knex file. But in order to avoid writing that every single time, we're going to go ahead and add it to the scripts to make it easier. And now with that in mind, we can go ahead and create the migration. So we'll need to write Knex migrate make, and then write the following: create to-dos table, which is the migration name that I've decided to give it. You can give whatever name you decide. And as you can see, after we run this command, it creates not only a migrations folder underneath the DB file, the DB folder actually, it also creates again here the migration file, also with a timestamp, so this is always going to be run in chronological order. So as you can see inside this file, we have an up and a down, which means that each time that we do the migration up, it runs this function, and each time that it does the opposite, it runs this function. Now inside the up function, we're going to add the following. First of all, we need to return something. If we don't return, this is not going to work, and this has happened a lot of times to me, so make sure that you have return right over here. Then write schema, and then dot create table. Here we're going to define the table name, which is going to be to-dos, and then we're going to pass here a function. We're going to pass here the table object inside this function, and then inside this function we can define all the columns for the table. So we're going to basically start by creating the ID, which is going to be .uuid. Then we're going to define this as the primary key. We're going to tell it to PostgreSQL that is not nullable, and finally we're going to default to Knex.raw uuid generate v4, and what this means is the following. Basically, we're going to create a unique identifier ID. So instead of just having 1, 2, 3 and then having it increment, we'll have a unique identifier for each to do. Then we're telling Knex that we want this to be the primary key. We want to tell it that it cannot be nullable, and finally we're defining this the default of this value as uuid generate v4, which means that inside of PostgreSQL it is natively going to generate a unique identifier for you. And in order to make sure that PostgreSQL can do that natively, you want to go inside your database. I'm going to use, in this case, Beekeeper Studio. You can go inside the terminal and enter your PostgreSQL instance. I'm using here, as you can see, the database that I've set up on the config file for Knex. and then you want to write create extension if not exist UUID dash OSSP, and basically then run this command. And as you can see, this is basically going to create the extension. If it doesn't exist, it is going to create the extension that allows us to natively create unique identifiers inside of PostgreSQL. So make sure that you do this before continuing. If not, PostgreSQL is going to give you an error. Now that we have set up the ID, we need to next add the title. So we're going to add table.string. The title is going to be a string. And then we want to define this as not nullable also. So again, the same thing here, we define it instead of being a unique identifier, it is a string. And then also it cannot be nullable because we always want to have a to-do with a title. We don't want to have an empty title for the to-do. Now we need to add table.boolean and define this as the column name as done. We're going to make sure that it's also not nullable, and finally we're going to default to false. Now we could do this, we could default it to false inside our code, but to make sure that we keep the integrity of the database at a database level, we want to make sure that PostgreSQL automatically defaults this to false each time that we create a new record inside the database. So again, it is a boolean, which means that it is either true or false. We're going to call this done. So when we check and uncheck the tasks, the to-dos in this case, we can basically keep track if it is done or not. And again, it is not nullable and it defaults to false. Now we want to add the timestamp. So in order to do that, we need to go ahead and write table.timestamp. Then we'll define created at, which is the name of the table, of the column. And finally, we want to also define this at not nullable. Then we're going to call this one updated at. So basically these are the same thing, but we want to keep track of when this was created and also when was it updated, so we can always know exactly when the records basically are created again and updated. And finally, for the down function, we're going to do the same thing. First of all, we need to return. Then we want to add next.schema, but instead of creating the table, we want to drop the table, and we simply just need to pass the table name. So as you can see, this is our migration file that's going to create basically columns that says that identifies it by a unique identifier. Then we'll have a title, if it's done or not, and also the timestamps. And now we can go ahead and run the migration. So if you come again inside the terminal and write yarn next migrate, and then do latest, basically this latest means that it is going to run all the migrations. In this case, we only have one, but it's also going to run this, so we can just go ahead and run this command. And as you can see, it just created one new migration, which means that all of this was just created inside PostgreSQL. And now inside of Beekeeper Studio, as you can see, we have here the to-dos. We have also the next migrations table basically, but we want to take a look at this. As you can see, an ID, which is UUID, title, which is a varchar, which means that it is a string, it's variable of characters. Then we have a boolean, done, and created and updated at as timestamps. So basically this means that it was all successful and that we just created a new migration inside of PostgreSQL. Now we need to create the model. So basically we now have a way for Knex to communicate with PostgreSQL, but we don't yet have a way for the code to communicate with PostgreSQL, and that's what the model is going to be for. So first of all, go ahead and create a models folder inside the database folder, and then inside of this you want to write todo.ts, which is going to be the model for each to do. Now we'll start by importing model from objection, and then you want to export a class that's called to do, which extends the model object. And inside the vir, we need to add a couple of things. First, we need to start by adding static get table name. and this is going to define the table name for this for the to-dos, and then we'll return to-dos. And basically this is going to let the model know that to-dos is a table name that we are working with. Then we need to add an ID, and you also need to add this exclamation point right over here. And then we'll define the ID as a string, so that TypeScript knows basically that this is a string. So we're not again using IDs as numbers or integers, we're using a unique identifier ID, so that's why we need to define this as a string. Then we need to add a title, which is the same thing. We also need to add the done, which is a boolean. And finally we need to add created at, which is also a string, and updated at, which is also a string. And again, just like I mentioned before, created at and updated at inside the database, it has an underscore between the words, but because we are working in JavaScript, we want it to look like this, because all JavaScript usually works like this. And to keep it more consistent and to make sure that we are not confused with it, we're going to work with it like this. And finally, in order to make sure that we have timestamps that work, we need to add here before insert, which is a function, and then going to define each time that it inserts a new date to ISO string. And we're going to do the same thing for updated at, and then we're going to also define before update. And we can go ahead and copy this and paste it right over here. And as you can see now, each time that a new record is created, it defines the created at and the updated at as the current time when it is updated, when it's inserted. And then each time that it is updated, it only updates the updated at record. And with this, we basically have timestamps inside our database. Alright, so now that we have the to-do model created, we need to go inside our code and add routes. So here's exactly what I mean by this. You want to come to the source folder, create a new routes folder, and inside of here, write todos.ts, and this is where we're going to define all the things, for example, forgetting, updating, inserting new data inside our database from the server request. Okay, so now inside this file, we'll start by importing, first of all, express from express, and then we also want to import the to-do model from our folder right here, so db models to do. As you can see, VS Code did it automatically for you. If it doesn't do it for you, you can just go ahead and import it from here. Then we need to define a router, which is going to be express.router, and again make sure that you set this as a function and not just router, because if you don't, it will not work. And then we'll start by defining all the routes that we need in order to manipulate our to-do data. So we're starting first of all with the get, then we'll define this as an async function, we'll pass the request and the response, and then we're going to do the following. Now we need to access this information from the database using the model. So here's exactly how we're going to do this. First, we're going to define this as to-dos, and then we need to await for all of this to happen. So what this means is basically that the code is not going to continue until this happens. And then we're going to write to do query select and then order by created at. And since this is a string, we need to define it as is defined inside the database. So here's exactly what this means. This route is basically going to index all our to-dos, so that we're going to next be using inside the client to show a list of to-dos. And again, we define here, we need to always write here query, a function, then we want to select all the records from the database and we want to order it by the date in which it was created. And finally, we're going to send the response back with the to-dos object. Next, we need to define the route for each to-do. So here's exactly what I mean by this. If we need to grab just a single to-do, we're going to do it like this. Again, write router.get, then we want to define here the ID like this, which means that we're going to pass the ID via the URL. And then again, this is an async function. And inside this asynchronous function, we're going to first of all grab the ID from the request object. So express gives us by accessing then the params, and finally inside the params it is the ID. And then we're going to access the to-do by awaiting for todo.query .find by ID, and then we're going to pass the ID and we're going to tell this right over here that we only want the first, and this means that instead of giving us back an array, the first is only going to give us the first record inside that array, so we can just get an object, which is not going to happen here. So here in the to-dos we're going to get an array of to-dos. Here we just want one to-do to be sent back from the server. And finally just write send res.send actually, and then pass the to-do in here. Next, we want to create the route that is going to allow us to create a new to-do. And in order to do that, again, just write router.post. We're going to let this be like it is right now. So it is going to be a default path. And then this is also an asynchronous function. Then we're going to pass the request and the response. And we're going to access the to-do params from the request.body.todo. So we're going to pass basically an object with the key of to-do that has all the parameters, that basically has, in this case, only the title. And then in order to create the new to-do, we're going to set it first as a constant, so we can then access it. And then we're going to go ahead and do await todo.query. Then we're going to insert it into the database, and the title is going to be todo.title. And finally, since we're using PostgreSQL, we can do the following. We can set it as returning all of it. And here's exactly what this means. It means that we're going to basically insert inside the database a new record with the title that was just passed from the body. Since we've defined that it is done, the done is basically set as default to false, we don't have to set here. We could do this right over here and set done as false, but since we did that at the database level, we don't need to do it. And finally, we'll set returning and we'll set here a star, and what this means is that it is going to return all the columns, so we can access the ID, the title, the done value, and the created and updated at values too. And finally, we need to res.send, so we can send back the to-do, which we've defined as new to do. Now we need to define a route that is going to allow us to patch a record, and what this means is basically a route that is going to allow us to, using the ID, update either the title or the done. In this case, we're only going to update the done state. So in order to do that, again, write router, and then in here we're going to use the patch. And inside of this, again, we'll need to pass the ID, an asynchronous function which has a request and a response object, and then we need to access the ID, which you have right over here, which is going to be the same, and then we need to also grab the to-do from the request.body.todo. And finally, in order to update the record, we need to do the following. Right here we'll set this as updated to do. Then we want to await for the function. Then we'll define to do query. And then we'll tell Postgres that we want to update with the following param. So we'll basically update the title in case we updated like this. And if not, we're only going to update to do that done. I'm going to add both of these right over here so we can update it from our REST client, but in this case inside the React application we're only going to update the to do, the done state. And then we want to update a particular record, and in order to let PostgreSQL know that, we need to let it know where. And we're going to tell it that we want it to update the record that has the ID that is passed from the request. Then we also want to return again all the columns, and finally we need to also only return the first record, which means that if we didn't do this again, it would return an array, but since we are only handling one particular object with one ID, we don't want that to happen, so we're going to return only the first record. So as you can see, this is all that we need in order to update and then return the updated value back with the new updated at and the new done state to the client. So now with this done, we can go ahead and write res.send, then define the to do as the updated to do. And finally, in order to be able to delete a record, so basically in order to be able to delete a new a to do that we created, we need to go ahead and do the following. First of all, we're going to define the path as ID. So you need to write here router.delete. The path is going to pass the ID, and then we need to again define this as a synchronous function. We're going to pass the request and the response object, and then we're going to again access the ID, and we're going to await for to do that query that delete by ID. Now we could do this. We could do the same thing that we did right over here, which is update where. We could do here delete where, but since objection provides us with delete by, we can just go ahead and use that and pass in here the ID. And finally, we're going to go ahead and res.send a simple message that says to do successfully deleted, so that we know then on the client, on the REST client or on React, that this value, this to do was just deleted. And with all of these routes defined, we now need to export this router right over here, and we're going to do that by writing export default router. So as you can see, we're basically going to define all of these routes using this, and then we're going to export it so you can use it inside the index.ts file. And now we need to go inside the index.ts file and do the following. We want to write app.use, which basically means that we're going to use a router which allows us to separate routes between files, and then we're going to use it as to-dos, and then we're going to set here what the handlers are, which is to-dos. So we need to import to-dos from routes and to-dos, and now that we have it imported, we can go ahead and set it right over here. And now this, in the same way that this path right over here on the default, so if you go to HTTP localhost 9001, it receives back this. If we go to the same path, but if we define to-dos, this is going to direct us to this file right over here, and it is going to allow us to basically compartmentalize the code and all the routes. So with all of this done, we can go ahead and start the server. And as you can see, it started, it's all going correctly. and then we can go ahead and try all of these routes. So first of all, we're going to post to localhost 9001 to-dos a new to-do with a title of wash the dishes, and as you can see, we get back the to-do, the title, and all of its parameters. Next, we can go ahead and copy this ID, and after we copy this ID, if we add it right over here and we want to get the to-do with this ID, we'll get the to-do back, and if we want to index all the to-dos, it is going to also index. And also, just as an example, if I add here pay the bills, for example, and I run this, as you can see, it gave back also a new one. And if I go ahead and index it again, it is going to go ahead and give me not only the wash the dishes, but also the pay the bills. Now I'm going to go ahead and grab the wash the dishes ID, and we're going to go ahead and try to patch it, and instead of having the done as false, we want to patch it to have it as true. And as you can see, it just gave back true. And not only that, but if we go ahead and make the request again, this one is false and this one is true. And finally, if we go ahead, grab the pay the bills, and we add it right over here to the delete one, the to-do was successfully deleted. And again, if we go ahead and try to grab all the to-dos, it is not available right over here. So as you can see, we are now able to create, read, update, and update the to-dos. Alright, so now that we have the entire server working and all of the routes set up and working, we can go ahead and first of all close all of these files. Just close this folder right over here and leave the server running, because we're then going to be using it as we start building the client. So I'm going to start by creating here a new terminal, and then inside the terminal you want to first of all create a new file, a folder actually, called client, and then inside of this folder you want to go ahead and write the following: yarn create React app dot, and then we're going to use a template of TypeScript. And what this is basically going to do is going to create us a new create React app, which is the most used, I think, boilerplate for React. So with that in mind, go ahead and run this command. Alright, so as you can see, the create React app was just created, and if we go ahead and run yarn start, it is automatically going to go into the browser, and it is going to go to localhost 3000, and as you can see, we have here a React app working. Now the first step is for us to come into this folder right over here and start cleaning up all the things that we don't really need. So I'm going to start by deleting app.test, because we're not going to write tests in this tutorial. Then we also want to delete app.css, and we also want to delete index.css and also the logo, which we're not going to be using. And then inside here, the app.tsx file, I'm going to define this as an arrow function. And I'm also going to define this as a React functional component. I'm also going to delete the logo and the CSS. And I'm just going to leave the application with a little piece of text that says to do yours right here, so I know that this is working. And now I'm going to go into this index.tsx folder, and I'm also going to delete here the CSS, and as you can see, the application is still running only with to-do areas, which is what we defined inside the app file. And also I'm going to move this app.tsx file into a new folder that we'll call components. Now this is a basic thing that a lot of applications have. This is a structure actually that a lot of applications have, which is housing all of the components inside a components folder. So I'm going to go ahead and do that, and I'm also going to let VS Code automatically update the imports. So as you can see now, instead of just importing from app, it is going to import from components and then app. And if you go ahead here, as you can see, it is still all working well. Now, the first thing that we need to do is to add routes to our application. And what this means is that each time that we go, instead of going to just local 1000, we want to, for example, come to new and have the page that is going to allow us to create a new to-do, for example. So in order to do that, we need to first of all open a new terminal and then cd again into the client. Make sure that you are always inside the client when you are doing these commands. And then we want to start by adding a tool that's called React Router DOM. And also, because we are using TypeScript, you also want to go ahead and add it as a dev dependency, the types for this library, which is types React Router DOM. Now, before going ahead and setting up React Router, I'm going to do the following. I'm going to create two new components, one that's called new to do actually, .tsx. I'm going to start by importing React from React. Then I'm going to define here new to do, which is a React.functional component. This is also going to be an arrow function, and this is going to return just a div that says add. So for example, new to do, just so we know that we are inside this page, and then we're going to export it as default new to do. And then I'm going to do the same thing, but only for a different one, which is going to be called to-dos. So this is where, again, we're going to list all of our to-dos. I'm going to paste this code right over here. And then I'm going to replace this and inside of here with to-dos, so that we know that we are working inside this to-do file, and in this case, the new to-do. Now, inside our app.tsx file, we can go ahead and start by importing from React Router DOM the following things. First of all, we'll import browser router as router, so we'll use it as router. Then we also want to import switch, and finally route. And now inside the application right here, we want to add the following. First of all, we want to start by deleting this div, which you don't need right now, and then add here the following. First of all, we'll add the router, which is going to be at the top of all of this. So the switch and the route needs to be childs of the router. The router is the parent. And then we need to add here a switch, which basically tells React Router DOM that we're going to switch between these routes. They are not going to be handled at the same time. And finally, we're going to define our routes, which for the path of new, we're going to add the new to do, and then we're going to do the same thing, but only for the default path, which is basically localhost / just, so where we are right now. And then inside of here, we want to add the to-dos. And this is all that we need in order to set our routes. And as you can see right now, if you come here, it defines this as to-dos, which is this thing right over here. And if we come to /new, it is going to give us the text that we defined inside of new to do, which let us know that the routing is working. Now we need to install Chakra-UI, which is the UI library that we are going to use. And this basically means that Chakra gives us a bunch of components that allow us to create user interfaces with a lot of ease. So in order to install it, instead of me just telling you exactly all the packages, you can just go here to Chakra-UI.com, and then if you come into the docs and getting started, we can go ahead and copy all of this and add it into your terminal, and then just run the command, which is going to install Chakra. It is going to install emotion, emotion style, and also framer motion. Now we want to go ahead and set up Chakra inside our main file, so inside the app file. So we'll start by importing the Chakra provider from Chakra-UI/React, and then you want to make sure that it becomes the parent of all of this code. So you want to add it even as the parent of router, and then add it like this. So this is basically all that we need in order to set up Chakra. So now if you come back here, Chakra is already set up, and as you can see, the text became a little bit different because it did a reset on the CSS. But now we also want to do an additional thing, which is set up a custom theme for ourselves. So in order to do that, just come into the source folder and add a new file that's called theme.ts, and then you want to add the following code. First of all, start by importing from Chakra, again, UI/React, the extend theme. And then using the extend theme, we want to export not as default but as a constant name theme, and then we want to extend the theme, and then we're going to add our custom colors inside this object. And in order to do that, first of all, we're going to define here the colors, and inside of this I'm just going to paste all of this code, and here's exactly what that means. This means that inside the colors of Chakra, instead of using the default colors, which is usually gray 50, 100, so it is basically a color scale, I'm going to use something a little bit simpler, which is just yellow, light, default, and dark, and also gray, light, light, dark, default, and dark, and these are the colors that I'm going to be using inside this project. And then after defining the colors right here, you can then access them inside the components that we're going to be using with Chakra. And in order to set up this theme inside our application, you need to go ahead here where we've set up the Chakra provider. You need to set up a theme, and then the theme is going to be this folder, this file right over here that we just created. So it basically imports this constant right here, and it tells Chakra that these are the colors that we also want to use inside our components. Now the next step is for us to create all of the design inside our application, and we're going to start by creating the design for the new to-do page. So as you can see, now we just have this right over here, but we're going to start by creating the design now. So the first step is for us to import here, as you can see, box, and then we'll start from here. First of all, we need to add here empty, which means margin top. So on the top we'll have a margin of 24 points, which if you multiply by 4 is going to give you the pixels. Then we'll have another box inside of here with the width of 384 pixels. And we also want the margin on the left and the right, which is what this X means right here on the X axis. We also want it to be auto. And inside of here, we want to have the following. We'll start by adding a text. So as you can see, these are all components that we are importing from Chakra, the box and the text. The text is going to have a font size of 18 pixels. The font weight is going to be bold, and the color is going to be, again, we just defined here on the theme, so you can access the gray.default, which is what we're going to be using here, gray.default. And here we'll just let the person using the application that this is the title. As you can see, this is where the design starts. Then we'll add an input, and the input is going to have a margin at the top of, again, 4 points, which means that it is 16 pixels. Then the name is going to be title, the border color is going to be of gray light, the border width will define it as 2 pixels, and finally Chakra also gives us the ability to set the border color of the focus state. So essentially we'll also pass this as gray light dark. Now we don't need this right over here, we can just close itself. And then, as you can see, now we have here this input right over here, and then we'll add also, after adding here some space, we'll add the button, which is going to have margin at the top of 6. Then the color is going to be gray.dark, the background color is going to be yellow.default, and we'll also define the following. We need to define on hover the background color yellow.dark, and we'll do the same thing for active, but we'll define this as light. And inside the button we're going to simply add new to do, which is going to be the contents of the button. And as you can see, this is the result that we're left with. So again, we have here the title, so that someone that's using the application knows that this is the title, and then we can click here later to add a new to do. Now if we go ahead and we try to write something here, you can see that it changes, but we need to access this value right over here, and we're going to do this by doing the following. First of all, we want to define here the title and the set title, and we're going to be using use state from React, and the default is going to be the following. And what this means is basically that this is the value that we want this state to have, and this is the function that we're going to use in order to set a new value each time that we want to change it. Now we first of all have to come in here to the input, set the value as title, and then we want to set on change a new function that passes the event, and then we want to set the title as the event.target.value. And what this essentially means is that now each time that we go ahead and change this, it will be stored into this variable right over here. And just to show you something, if we change the default here to this, each time that we refresh the page, it is going to have this value, which means that this input right over here, we can now not only control it, but also access its value. Now the next step is to do the same thing, but for the to-dos file. So in order to do this, before we connect this to the server, I'm going to start by creating a simple array with our to-dos, for example, and then I'm going to define here a couple of to-dos. Alright, so now that we have here a simple array of to-dos with simply the title and the done state, we can go ahead and start creating the design that we'll be using inside this application. So just like with the previous file, we'll start by adding here a box, and then inside this box we'll define the box margin top again as 24 and the margin for the left and the right as auto. And then inside this box we want to add a flex. So if you're familiar with CSS, we're basically going to use the flex API in order to center the basically a small box that we're going to show and to display the to-dos. So you need to do the same thing as we did with box, but with flex. And then we're going to define the align items at center, justify the content also at center, and the position is going to be relative because we want to add a button that is going to have the position of absolute. Then we're going to define another box with pixel with the padding to the sides of 8. Then we'll define the padding on the top as 6 and the padding on the bottom as 10. Then the background color is going to be gray light, which again we're accessing from our theme. The border radius is going to be 16 pixels around it. And finally we'll use this right over here, which as it says it's experimental, but what basically does is it creates a space between items. So we want to have a space vertically between our to-dos, and we're going to set that as 4 points. And now if we go ahead and map our to-dos and we pass here one to-do, we can go ahead and access in here the to-do.title. If you go back here, it should be working. As you can see, we defined here the entire design, and it is now showing wash the dishes, pay the bills, and walk the dog. So let's continue. Now inside of this, instead of having a simple div, we'll set a flex box again, a flex component actually, and then we'll set this align items as center, justify the content, we'll space between, so we have the title in the middle, so the to-do in the middle, and then the trash on the right, and then the check or check on the left. And we'll again use this experimental space, this time with x set as 4. And now inside of this we want to add not only the title but also 2 icons, and in order to do this we're going to go ahead and install a library that's called React Icons. So you can go ahead inside the terminal again and just write yarn add React Icons. Now we can get back to our code and start adding the icons and the text. So we'll start with the text first of all, which we need to import, and then the text is going to have a color of gray and dark, and the font size is going to be XL, and its contents is going to be the title of the to-do. So we'll set again here to-do.title, and now we can go ahead and add the icons. So we'll start by first of all importing from React Icons, and then we need to add /fi, which means that we're going to not only import from this but a sub folder, and then we're going to add fi check square and also fi square, which means that we're going to import check square and square from the feather icon. So this is a open source library that provides nice icons, nice looking icons that we're going to be using inside this application. So now we can go ahead and write here icon, which is going to import it from Chakra. And then we'll start by first of all defining its size, which is 2XL. Then we'll define the color, which in this case is gray dot light gray. Then we want to add the cursor as pointer. And we finally want to add here, when the state is hover, a color of gray dark, which basically means that this is going to be darker when we hover over it, so we know exactly what's happening. And finally, we need to define a rule that lets us know if the to-do is done, we need to add a check inside the square, and if it's not done, we need to just add a simple square. So we're going to do the following. In order to connect Chakra to React icons, we need to first of all add here as, and then inside of here we're going to do the following. We're going to add done to-do.done, an interrogation point, which means that if this to-do is done, we're going to be using the fi check square, and if it's not, we're going to simply use the fi square. And here's exactly how this is looking so far. Again, the wash the dishes is done, pay the bills not, and walk the dog is done. And as you can see, if you hover over it, it doesn't change the color, which means that we did something wrong. So as you can see, instead of being light gray, we needed to add light dark, and now it should be correct. So as you can see again, it shows us exactly what the state is. Now we need to add the same thing only for delete. So we'll again come up here and import an icon, which is a trash. And then again, we'll define here an icon. Just going to give here a small space. And then the icon is going to be red.300, which is a color that Chakra provides us by default. The hover state is going to be of color red.700. Then we're going to have the font size as 2XL. The cursor actually is going to be a pointer. And finally, we're going to define the same as, but since this one is not going to change based on the state, so if this changes right over here, this also changes. But here we simply need to add just fi trash, and it should be looking good. As you can see, if we hover over it, it becomes a little bit darker, and same thing for this right over here. And finally, we need to add an icon button that basically allows us to navigate to the new path, which will then allow us to create a new to-do. So to do that, we need to add here an icon button. We need to make sure that it is imported, so I'm just going to go up here and make sure, yes, it is imported. And here are exactly what the params for this are. We'll start by adding a color, which is going to be gray.dark. Then a background color, which is going to be yellow.default. Then a border radius of 100%, which means that it is going to be round. We also need to add an area label. So basically this is for accessibility purposes. We'll add this one as add new to do. Also we need to add here the size as large. The position, the padding actually is going to be of 4 pixels. The position is going to be absolute. The left, since we are using an absolute position, we can use the left to position this button. So I'm going to use a calculation, and then we're going to define this as 50% minus 24 pixels, which is going to give us a perfect centered button. And finally, this is also going to be cursor pointer, and the hover state is going to be of background color yellow dark, and the active is going to be of light. So the result is the following. As you can see, we have here a simple button. Now we just need to add the icon inside of it. And in order to do that, we'll simply again add here this, and then we'll import an FI plus. So as you can see, it automatically imported it right over here. And now if we go back here, as you can see, we have a nice looking button that allows us to add a new to-do. Alright, so now that we have the entire design set up, we can go ahead and connect the client to the server, so that instead of this showing up right over here, we can actually see the data that's coming from the server, and that we can also delete and create new to-dos. So in order to do that, let's start by adding two different libraries, which are Axios, which is the library that is going to talk to the server, and then we're going to use React-Query, which is a state management library. Now, I did a previous video just a couple of days ago, I'll leave it in the description below if you want to watch it, where I compare and I talk exactly why Redux is not perfect for all situations, and it is not perfect for this type of project. In this type of project, something like Apollo Client or React-Query work really well, and that's why I'm picking React-Query for this project. So with that in mind, go ahead and run this command. Now that we have React-Query and Axios installed, we'll basically start by setting it up. So first of all, you want to start by importing from React-Query the two following things. First of all, React client, and then query client, and then query client provider. And also we want to import from React-Query DevTools the following. We want to import React-Query DevTools, which is going to basically allow us to see exactly what's happening in real time on our application. So now we need to go ahead and define here a new constant that's called query client, which is a new query client. So we're going to initialize this object. And then we need to go ahead and wrap this application around this query client provider. So to do that, we're basically going to do this. Then we need to define the client as the query client that we just created. And finally, we're going to make this happen. So as you can see here, we have here the query client provider, which the client is again what we just created here, and it is wrapped, the app is wrapped around this, which means that all this data that is coming from here is going to be sent into the app. And also to make sure that we have DevTools, so basically that we can debug exactly what's happening inside the application, we'll also go ahead and add this right over here, React Query DevTools. And as you can see now, if we go ahead and refresh this page, we now have this right over here, which means that we now have React Query installed into our application. Now the next step is for us to create an Axios instance, and here's exactly what I mean by this. Let's start by creating a utils folder right over here, and then defining here a client, which basically means that is the thing that is going to talk to the server. Now we'll start by importing Axios from Axios, and then we'll export a new constant, which is client, and this is going to be the following: Axios.create, which means that we'll create a new instance of Axios, and we'll define a new base URL, which is HTTP localhost, in our case 9001, which is what we defined in our server. And also we'll define a timeout of 1000 milliseconds, which means that after this time has passed, the request cancels itself. It doesn't wait forever. So if something bad happens, it is just going to time out, and you don't have to stand there waiting forever in order for it to basically instead of, if you don't have, for example, an error message that is being automatically sent from the server, or if you don't have a catch in your functions, then this is really going to help. Now, the reason we are doing this instead of directly using Axios is because we don't want to all the time have to write this localhost 9001, and this really helps us with writing code a lot faster. Alright, so now that we have the client set up for Axios and we also have React-Query set up, we can start by creating our first request to the server. So the first request that we want to make is the one that is going to load our to-dos from the server. So you need to write the following. First of all, we need to deconstruct this thing right over here, so the use query function that we're going to be using, and then we're going to define the data as to-dos, and we need to write the following. We need to write, as I just said, use query, which we want to import from React-Query, and then we'll define this query as to-dos, and the function that is going to get the data is going to be client, which is the client that we just created inside the utils folder. And then we're going to get to-dos, which is the to-dos path. And then after we get the response from the server, we're going to access the response.data.todos. And this basically means that we're going to return the to-dos instead of just the data object that is going to give us. Now, since we are using TypeScript, we also need to define the type of to-do. So we're going to go ahead and do just that. First of all, write type to-do equals, and then we're going to set this as ID of string, title of string, the done, which is going to be a boolean. We'll set the created at as a string, and finally the updated at also as a string. Now this basically means that each to-do is going to be of this type, and it is going to have all of these values. And now we need to come in here to use query and define it the following way. We need to open this, and inside of this we need to add the to-do. Now the reason we are adding here these two things, so like an array would be, so we're opening an array and closing an array, is because we are not just fetching from the database one to-do, but actually an array of to-dos. And now we can go ahead and write the logic for our page to show the to-dos once they are queried. So the first thing that we want to do is delete here the to-dos that we created, and now we want to write here if is loading. We want to return null, so a blank page, and then if we have the to-dos, we want to return this code that we have right over here. And finally, if there are no to-dos, so again, it's not if there are no to-dos. If there's an error, we want to also return the null. So now, as you can see, it is now giving us an error right over here, and that's because our to-dos doesn't exist, but to-dos does. And now if you come here, as you can see, it is still complaining about our to-dos. Let's see if we still have it somewhere around here. We don't. So we just need to give it a couple of refreshes, and as you can see, this is the wash the dishes that we just created here. Before, when we made the first request, we created the wash the dishes to do. So that's exactly what's showing up right there. And this means that we now have the client connected to the server and requesting all our to-dos. Now we'll go ahead and create a mutation, which basically means there is a request that is going to change data And in this case, first we'll start by creating a mutation that is going to toggle the to-do. So we'll call this one toggle mutation, and then instead of use query, we'll use on this one use mutation. And here it doesn't need to have any key, as we have right over here. We can just go ahead and pass in the function. We need to pass here the to-do, which is the type of to-do, and then we'll use the client and we'll use the patch, since it's what we created on the server. And here we'll use to-dos and we'll pass the to-do.id. And what this means basically is that we'll call the patch, as we just did right over here, in order to update this value, and then it is going to return it as it is. And now we can go ahead and add the data in our request. So we're going to add in here, as you can see, it asks for a data which can be of type any. So we'll add the to-do, and then the title is going to be of to-do.title, and the done state is going to be the to-do.done, only it is going to be the contrary value. So basically what I mean by this is this value right over here tells that if to-do.done is true, it is going to pass false, and if it is false, it is going to pass true in there. So basically it is always going to pass the boolean value, the contrary boolean value. Now we can go ahead and save this just for formatting purposes. And finally, inside of here, we want to add on success. So basically this is now handling, we are now adding this to the use mutation. We've already done everything that we need inside the client patch. And on success, we want to make the following happen. We'll start by first of all defining, let's define it up here, a query client, and then we'll use the query client, which was automatically imported, as you can see here, from React-Query. And again, on the onSuccess function, we want to query client that invalidate queries, which basically means that each time that the new that the mutation of toggle happens, it invalidates all the to-dos and it updates the correct state for the one that we just updated. Now the next step is to simply come to the icon that is going to handle that toggle and do the following. On click, so each time that this icon is clicked, we want to do the toggle mutation, and inside this toggle mutation we have a lot of properties right over here, as you can see, but we're going to use the mutate one, and we're simply going to pass in here the to-do that we're handling. So as you can see, we map it, we pass here the to-do, and now we're going to pass this to-do into the mutation so we can make sure that it toggles. And if we did this correctly, we can now go ahead and refresh this page, and as you can see, each time that we click, it not only toggles, but if we refresh the page, it stays toggled. Now before we continue, I'm going to go back here to Insomnia, and I'm just going to create a couple more tasks, to-dos actually, just for us to see right over here. As you can see, we just created and they appear right over here, because now the next step is for us to do the exact same thing, but only for the delete. So we'll start by adding here delete mutation, then we'll do the same thing, use mutation, and then client.delete, and here we're going to pass the following. We'll add here to-dos, and then we're adding in here the to-do.id, which I forgot to add right over here, but we can now go ahead and add it now. And as you can see, we did exactly the same thing, use mutation. The only difference is that we added here client.delete, and then we passed the to-dos and then the to-do ID via the URL. And now we want to do the same thing that we did on the toggle mutation. So we're basically going to on success pass a function, and then we're going to invalidate the queries once this delete mutation happens. And now we can come down here and we can add here the delete mutation that mutate to do, which is basically going to delete the to do that we click on. And as you can see, we have here 3 different paid bills, and if you click on one of them, it disappears. And if we refresh the page, it's also gone. As you can see, it deletes again, and if we refresh the page, the paid bills is now gone. Now we basically need to do exactly what we did here. The only difference is that we need to do it for the new to do. Now before we go ahead and do this, first of all, add here the following code. We need to add const history equals use history, and we're basically doing this for us to have the ability to click here and go to the new page. And then we're going to go down here to this icon button, and then on click, so each time that we click on that add new button, we're going to history.push. So basically we're handling the history on the browser, and then we're going to push a new path, which is new. So as you can see now, each time that we click here, it goes to the new page, and if we go back, we have here our to-dos. Now we can navigate the new to-do file and do exactly what we did with the previous example. So we'll write here const that mutation. So in this case, we only have one mutation, so we do not need to distinguish between them. And then we'll use mutation. We'll pass here the new to do, which is going to be of type to do, and then title string. And then we again import the client. We need to post to to-dos, and the data is going to be the new to do. And now we'll start by first defining again here the history, which is going to be use history function. And then on success, instead of just invalidating the queries, we want to push this into the default path, which basically means that it is going to navigate back to the to-dos and show the new to-do next to the other to-dos that we already had there. And finally, in order to make all of this work together, we simply need to come in here, add on click, and then pass here a function, and then we'll say mutation.mutate, and in here we'll pass the to-do with the title right over here. And again, if we did all of this correctly, we can now come in here, write for example walk the dog, and if you add the new to do, it appears down here, walk the dog. So again, we are now able to not only add, we can now toggle it, and we can also delete. And again, if we come in here, we can again walk the dog, and it appears right over here. And we now have an entire application. The client communicates with the server, and we are able to create, read, update, and delete to-dos using the PERN Stack. So if you enjoyed this tutorial on how to build a to-do list application using PostgreSQL, Express, and React, then leave a like below, let me know in the comments exactly what you liked about it, and subscribe for more content like this.